Good afternoon, advanced algebra students. I hope you are having an awesome day. I had a good time working with you in Zoom today, and I'm so happy to be getting to know you better as the quarter progresses. We are continuing on in Chapter 2. So far we've done lessons on 2.1 and 2.2 on slope-intercept form of a line and point slope. Today we're going to be talking about lines in standard form. So at the top of your paper, you can go ahead and write 2.3 standard form. And again, all that you need to write on your paper is what I put on the board, not everything that I'm actually saying. So standard form of an equation looks like ax plus by equals c. That's ax plus by equals c, where a, b, and c are integers, and a and b are both not zero. So in other words, if you look at it, the x and y are on one side and the constant is on the other. Let's do the first example, example 1. And again, don't feel like you need to write down the words, but we can just write down what I put on the board. So Hannah will spend $150 on music festival tickets. Reserved seat tickets cost $25 and general admission tickets cost $10. How can you represent the situation with a linear equation? So one possible way to handle this is to set x equal to the number of reserved seat tickets, and then set y equal to the number of general admission tickets. If we do this, then we can just set up the equation 25x, so $25 times however many reserved seat tickets she buys, plus 10y, so $10 for every general admission ticket she buys, equals $150. This $150 is what we call a constraint. It's a limitation, essentially, on how much she can spend. She cannot spend more than she has. So sometimes when we do word problems, it can be more convenient to put a problem in standard form if we want to be able to see the constraint when we look at the problem. Another thing that we might evaluate here is how does this information compare to if I put this same equation in slope-intercept form. So let's look at example 2, and let's take the same equation, 25x plus 10y equals 150, and let's put it in slope-intercept form and see how the information we can glean differs. If I subtract 25x from both sides, I'm going to have 10y equals negative 25x plus 150. And then when I divide everything by 10, I get y equals negative 2.5x plus 15. In this particular case, the 15, the y-intercept, would represent how many general admission tickets she could buy if she doesn't buy any reserved seat tickets. So we do get different information depending on what format the line is in. Okay, now what I'd like to do is talk about how to graph equations that are in standard form. We already learned how to graph equations that are in slope-intercept form or equations that are in point-slope form. If we have an equation in slope-intercept form, let's take the same exact equation, but we'll make this example number 3. So we've got 25x plus 10y equals 150. The simplest way to graph something in standard form, particularly if the coefficients of x and y go into our constant, is just to set up a t-chart, and inside that t-chart, on one of your rows have x be 0, and then on another row have y be 0. And what we're going to do is graph both of the intercepts, because our y-intercept occurs where x is 0, and our x-intercept is going to occur where y is 0. Now, if I plugged 0 into this equation, 25 times 0 would just become 0. So I would have 10 times y equals 150. If I solved that for y, I would get that y equals 15. So when x is 0, y is 15. I can do the same thing putting in 0 for y. If I put in 0 for y, I have 25x equals 150, and if I divide both sides by 25, I get that x is 6 when y is 0. Then I simply go ahead and graph those points. It might be easier if I skip counted by 3's on this graph, so I can do 3, 6, 9, 12, 15, and then maybe 3 and 6. So I would have the point 0, 15, and I would have the point 6, 0, and then I would connect those 2 points. So graphing an equation that's in standard form can be done relatively quickly if you set up a T-chart with 0 for x and 0 for y on separate rows. Okay, now what I wanted to do is one word problem with you. So we'll make this be example number 4. I will read the problem and then we'll set it up together. Tamira is making trail mix. I love the M&Ms in the trail mix. She has $40 to spend on a mixture of almonds and cashews and wants about the same amount of almonds as cashews. Almonds cost $8 a pound and cashews cost $10 a pound. How can she determine how many pounds of each kind of nut to buy? Write and graph an equation to represent the situation. Now notice we want to look to the end of our word problem and it asks, what is the unknown? And it says, how many pounds of each kind of nut should she buy? So we're going to have x be the number of pounds of almonds, and we're going to have y be the number of pounds of cashews. Then, if we want to set up an equation, we would simply write 8x plus 10y equals 40, because she's spending $8 for every pound of, almonds, and then 10 pounds for every pound of cashews. And then, if we want to graph this, again, we set up a T-chart. We put a 0 in for x on one of the rows and a 0 in for y on the other row. When x is 0, 8x goes away, and my remaining equation is just 10y equals 40, so y would be 4. And then when I put 0 in for y, the 10y goes away, and x is 5. So to graph this problem, I would graph the point 0 over and 4 up, and then I would also graph the point 5 over and 0 up. And this line would show us the different possible options that she could buy. Now, to find 2 solutions, all we need to do is find 2 points inside this area right here. So for example, since x is the number of almonds, we could buy 2 pounds of almonds and 2 pounds of cashews. So that would be one possible solution. Now, if she wants to spend a total of $10, it would end up being 2 pounds of almonds. And if we plug the 2 in for x, we would get 16 and subtract that from 40, and we would end up with 2.4 pounds of cashews. So that would be one example, 2 over and 2.4 up, that would fall either on the line or inside the line. Another possible example might be 2.5 pounds of almonds and then 2 pounds of cashews. So right there. So 2.5 pounds of almonds and 2 pounds of cashews. So that's just a very straightforward word problem that we could demonstrate using standard form equation. Now, what I want to briefly talk about at the end for example 5 and 6 is what would it look like if we just have either x alone or y alone. So for example, let's do example 5. What does our graph look like if our equation is just y equals 6? Y equals 6. the way I suggest that you graph this rather than rushing is set up a T-chart and say to yourself, okay, y is always 6. So I'm gonna put a bunches of 6 in for y. And since there are no constraints on x when the equation is in this format, I can put whatever I want in for x. I usually just do 0, 1, and 2. Then when I graph this, I know I'm gonna have 0, 6, 1, 6, and 2, 6 in my graph. And if I connect those dots, I will see that I actually have a horizontal line. And many students are kind of confused by that at first because they think that since the y-axis is vertical, the line y equals 6 should also be vertical. But in fact, this horizontal line represents all the points where y is always 6. So 0 over and 6 up, 1 over and 6 up, 2 over and 6 up, and so on. Okay, so you can probably guess what the last graph is going to look like. Let's look at example number 6. So if we look for example number 6, let's go ahead and graph x equals -2. Again, the way I would suggest that you think of this is x is always equal to -2. So set up a T-chart, and in your x column, put -2 a few times. Now in this case, there are no constraints for y. So I'm gonna put in 0, 1, and 2 for y. Then when I graph these, I'm gonna go 2 to the left and 0 up, 2 to the left and 1 up, and 2 to the left and 2 up. And I can see that the line x equals -2 is a vertical line where x is always -2. All right, I hope that that was somewhat helpful for you. We will go over a lot more details during class, and have a good day. Thanks, guys. Bye.